The topic at hand is agents or LLM agents. We're talking completion agents, streaming agents, agents with memory, RAG agents, React agents, plan and execute agents, agent swarms, multimodal agents, and more. First, let's take a look at the difference between completion agents and streaming agents. The takeaway is thumbs down for completion agents, thumbs up for streaming agents. Let's take a look at why. Here we have a chat UI for interacting with a completion agent. Let's say hello. Then I'll say, my name is Tad. Let me now say this. I just told you my name. I'd like to make sure you're listening. Can you let me know what my name is? What do you think it'll say? It should say Tad, right? Let's see. Completion agents are the most basic type of agent and consist of the following setup. Some AI model, in this example Claude 3 Sonnet, will be at the heart of a completion agent. The model will receive some input and will calculate an output. When viewed in this manner, an AI model is nothing more than a glorified math equation. After the complete output is calculated, it will usually be returned to whomever provided the input. Notice also how this highlights how once an AI model or math equation has been specified or versioned, it has no sense of memory beyond the versioning date. Let's take a look at two more examples. First, we will prompt Claude to summarize a 9-page paper, i.e. the Bitcoin white paper. Second, we will prompt Claude to write a song. We've been tracking these last two prompts with a tool called Langsmith, and we can see we've waited as long as 11 seconds when awaiting a response. From a UX standpoint, this is painfully slow. This long response time problem of completion agents is what is solved by streaming agents. What the LLM models that power these agents do is, given an input, will generate a small output called a token. A token is a common building block of the vocabulary that the model was trained on. Each generated token will be appended to the input and fed back into the model until a special token is generated called a stop token. This is why LLMs are sometimes referred to as autoregressive models. Given this is how output is generated, we can see how we don't have to wait until the complete response is ready before presenting data to users. We can send tokens back to the user as they are generated, token by token. This implementation detail is what defines streaming agents and is what makes them much faster in regards to user experience. Let's take a look at those same two prompts again to see this in action. First, let's summarize the Bitcoin white paper. And have the LLM write a song. We can see in Langsmith that we now have an additional metric being tracked called the time to first token. In the case of the summarization of the Bitcoin white paper, we only had to wait 3.5 seconds till we started receiving data. In the case of writing a song, we only had to wait half a second until we started receiving the lyrics. So long story short, thumbs down to completion agents, thumbs up to streaming agents. Streaming agents can be a bit trickier to implement, so I have included a reference implementation below that leverages LangChain, Python, FastAPI, and React. Enjoy.